Hello, ladies and gentlemen, and welcome to this talk about verification and validation assessment in genetic counseling and testing. I'm Ekaterina Auer from the University of Applied Sciences in Wismar. This is a joint work with Wolfram Luther from the University of Duisburg-Essen. The title of this talk has two major keywords. The first one is verification and validation assessment. My co-author and I have been working since several years on making verification and validation assessment reliable. We apply the concepts in the areas of biomechanics or visualization. In this talk, we are going to present the first step towards it in the area of genetic counseling. What is reliable verification and validation assessment? The usual modeling and simulation cycle shown here, with verification at the stage of implementation and validation at the stage of simulation, is enhanced using reliable data analytics, but also reliable visual analytics or reliable cognitive analytics. An important point here that also reliable computing can be used, which is in the focus of our talk today. At each stage of the cycle, certain methodologies and technologies are used, enhanced by some optional features. All these features, forms of uncertainty and its propagation are also in the focus of the talk today. The second keyword from the title of this talk is genetic counseling and testing. So what about that? What does it mean? Well, it is known that inherited mutations in certain genes increase the risk of cancer. And that is why patients might want to have them tested for certain gene mutations. However, it is not always recommended because the tests might be too expensive, but also it is because such tests are not always helpful for a patient. That is why the patients are not referred for testing directly. First, a doctor can take a look at the family history of cancer for a given patient. For that, or based on that, risk assessment tools can be used first to give us predictions about certain mutation probabilities, for example, or risk probabilities for a given patient. The pros and cons of genetic testing are explained here at the stage of genetic counseling. After that, the patient might have nothing to do with this genetic counseling and testing. The process might be finished, or the patient is referred for further genetic testing. After the results of tests are there, they need to be discussed again in a new session of genetic counseling. In the focus of this talk are two stages. These two stages of the process, we are interested in the question of those stages are reliable, with a focus on breast cancer. Important mutations for breast cancer risk are in the BRCA1 and 2 genes. BRCA1 and 2 are the so-called tumor suppressor genes. A gene change is more likely in a person having a family history of breast cancer. Other criteria might be closeness, number, or age of the affected family members. As we can see, there is a high degree of uncertainty in the process. Many studies or meta-studies deal with evaluating genetic testing, genetic counseling, and risk assessment. For example, those three relatively recent ones. You can observe that evaluation of studies results is mainly focused on aleatory uncertainty. Epistemic uncertainty is considered only indirectly through comparisons with other studies. Also, different studies use different criteria for test persons' ages, for example, or degrees of kinship. that often cannot be mapped to each other exactly. That is, it is necessary to work with sets while comparing approaches. So our contribution in this talk is a first step in the direction of the consistent and reliable verification and validation framework for risk assessment and genetic counseling stages. In the focus are the following points. First, we want to merge risk factors across risk assessment tools. We consider these four possibilities for that. After that, we want to introduce a new method combining the decision tree logic of this tool with other three remaining tools using interval analysis, where possible. And an important point here is not to overestimate the risk because it would impair patients in their decisions. So now let's turn to verification and validation of genetic testing first. There is an ISO guideline for doing so shown on the slide. So basically, verification and validation process depends on whether the technology is new or already existing. And we also see that an important step aside from verification here and ongoing validation is to give estimates for inaccurate risk assessment, inappropriate or incomplete testing results, misinterpretation of results, but also to have a focus on ethical, legal, and social implications. Also, in this process, there is a high degree of uncertainty or impreciseness. So, are there any schemes for genetic counseling comparable to that I've shown you on the previous slide? Well, not really. And to begin with, we propose the following. First, we need to define unified and consistent risk factors or criteria across risk assessment tools and studies. And we will show how to do this, or the possibility to do this with the help of interval analysis, which we propose in the second step. We need to work with sets for representing epistemic uncertainty if these risk factors do not map to each other in full. And then using methods with result verification, we can propagate this uncertainty through the models. And we show here one possible example, the extended referral screening tool. So at the second step, we need to handle uncertainty. And usually the aleatory uncertainty is handled with probability theory or statistics. The possibility to handle the epistemic uncertainty is to use interval analysis or other methods with result verification. If uncertainty is mixed, we can use Dempster-Sheffer theory of p-boxes or other things. Uncertainty is usually, or strictly speaking, not the same as impreciseness. For impreciseness, we can employ fuzzy methods. So this is how it is done today in the area of genetic testing or genetic counseling. We propose to enhance the traditional methods with considering epistemic uncertainty with the help of interval analysis, and to mix those kinds of uncertainty as a subject of our future work. I've already used a lot this keyword of result verification. So what is it exactly? Verification answers the question of whether we are building the product in the right way. There are different kinds of verification, for example, formal or code verification. The result verification proves mathematically that the result that we obtain on the computer is correct. So for this purpose, some fixed point theorems and set-based arithmetics can be used. An advantage of such a method is that we account for rounding and conversion errors. some method errors, but we can also propagate epistemic uncertainty through the system in this way. A disadvantage is that we might possibly have a too pessimistic or conservative interval for our output due to overestimation. So now let's turn to how to apply methods with result verification at the stage of genetic risk assessment. We can have two types of risk assessment. We can want to assess the chances of developing breast cancer over a given time span, including the lifetime, or we might want to assess the chances of a certain mutation in a high-risk gene, for example, BRCA1 or 2. The risk factors can be hereditary, family history based, for example, with such subfactors as age at onset or number of unaffected individuals in the family. But there are also a number of other factors, for example, hormonal or reproductive factors, or factors based on a patient's diet or exercise. There exist several established models how to deal with such risk assessments. For example, Frank tables or clause tables. Frank tables give us predictions for mutations in BRCA1 or 2, and they are correlated with the age of diagnosis, personal family history, and also ethnicity. However, they only consider or differentiate between Ashkenazi and non-Ashkenazi individuals. The empirical studies are fitted into a logistic regression analysis model, and big proband groups are used in this case. Closed tables models give us predictions for cumulative breast cancer probability, also considering age-specific risk, and also considering family history. Closed tables implement a Bayesian model based on smaller proband groups. In general, it can be said that Frank models are more pessimistic, but both those models do not include non-hereditary factors. So, although there are a number of established tools, also based on those tables I've shown you on the previous slide, to deal with such assessments of risks and probabilities, they are rather difficult to deal with in the conditions of a common doctor's office. That was the reason behind developing the next 3 assessment tools I'm going to show you, beginning with the anterior family history assessment tool. The goal of this tool was to develop criteria for who should be referred for genetic counseling and testing, risk factors, in such a way that they are easy to work with in the conditions of a common doctor's office. So there are several kinds of points that are given for each risk factor. The approach was to select those who are at approximately twice the population risk of developing breast cancer or ovarian cancer. The basis for the development were the opinions of experts. The scores that we can see here were validated using clause tables and other tools, and a person is referred for genetic counseling and testing is if they achieve a score more than 10 according to the system. And this corresponds to approximate doubling of a lifetime risk of breast or ovarian cancer. So, we can see that there are several factors, for example, for a relative having breast and ovarian cancer relative, like here. And we see here that points in the range between 5 and 10 are possible. That is, if we want to consider this criteria only, then we have actually a set of points from these intervals. So we see here in case of breast cancer alone, there is also a differentiation according to age, and there are also several other risk factors considered here. The next scoring system is Manchester scoring system. Its goal is to predict BRCA1 or 2 mutation probability in families suspected of having hereditary breast and ovarian cancer. So we see here there are a number of risk factors. They are not the same, exactly the same as shown on the previous slide for the other two. And the referral happens if a score of 10 in either column or a combined score of 15 is achieved. This corresponds to approximately 10% chance of identifying a BRCA1 or BRCA2 mutation. The simplest tool for a doctor to use is this referral screening tool. The goal of this tool is rapid identification of individuals at potential hereditary risk for breast and ovarian cancer, the same as previously, actually. So this tool is based on a number of established tools in this area. The criteria are really simple in this case. For example, Jewish ancestry, yes or no, male breast cancer in the family history, yes or no, and also several other criteria that we can consider here. Referral happens if 2 or more checks in the table are made by the proband or by the patient, and this corresponds to a proband being in the high risk group for breast or ovarian cancer. Actually, this does have a kind of a binary logic because the answers are also always yes or no. So, previously I've talked about that those tools can be merged, and here's the first possibility for merging. We go from the probabilities that are given by Frank tables to interval scores that are given by the family history assessment tool. Yes, if we take a look at the Frank tables, we see that they are defined for women. That's why we are giving the scores here only for female cancer in this case. And for example, if we take those risk factors from Frank tables, then we obtain those interval scores, and we see that the mutation probability for BRCA1 increases when we take more and more criteria into consideration, and this behavior is also reflected in the scores from the family history assessment tool. So how to compute, for example, the interval score for this case? So we need first to take a look at relatives having breast cancer, female relatives, and then the score would be from 2 to 4. And then because we need to consider any relative with breast cancer under 50 years of age, then we also need to combine the scores from this point of view and see that we obtained here an interval from 2 to 6. Then these intervals need to be added, which gives us the final score in this case. Yes, the next kind of merging that we can do is between family history assessment tool and Manchester scoring system. I'm not going to go into details here. This table is just for reference if you want to understand how we obtain the scores shown at this slide. Let's say shown on this slide where we present our extended referral screening tool. This is actually our next possibility for merging. Risk assessment tools often have a kind of a binary logic to them. That's why they are well suited for combining with multi-criteria binary decision trees. So such a combination can look like that. So we have some nodes containing function, or let's say containing a function for interval features, containing some decision rules, also containing some risk functions depending on the answer yes here or no there. For example, such a risk function can depend on scores, risk scores, and mutation probabilities. Some rules in the node can be exchanged, and the input data vector is propagated through the three two outputs. The output vector contains an interval risk score in our case and a mutation probability. And this index A, for example, denotes the binary decision path to the sleeve. It is written down in the decimal form and is read from left to right. So here is an example of how the referral screening tool can be merged with such a binary tree. So for example, here the criteria of or risk factor of Jewish ancestry, yes or no, can be combined with the next criteria of one male breast cancer at any age in any relative. So we have here one more criteria after that, and at this node the rules can be exchanged with the help of other criteria. So and those nodes have two further risk factors which can be considered. So that is, if we take a look at this path, then we see there are two ones in the referral path. That is the individual who answered those two questions with a yes would be referred for genetic testing and counseling. So in this case, if you answer this question with no, this also with no, and only this criterion is answered with a yes, then we have just one yes in the whole path. That is, such a patient would not be referred for subsequent genetic testing. And in a minute, we will see how we can combine that with three tools I mentioned earlier, with the family history assessment tool, Manchester scoring system, and Frank tables. This would have the advantage of bigger problem groups and also more information. So this is our proposed extended referral screening tool where we combine the binary tree with all the tools I've mentioned during this talk. For example, if we take a look again at this path 1 and 1, then we see that the mutation probability given by Frank table in this case is really high. Then the score from the family history assessment tool is also high. It is the upper bound is more than 10. That is, this patient would be referred for screening also if we use this tool, this family assessment tool. So only the Manchester scoring system would not refer this patient for further screening. So, but all the other three tools recommend screening. That's why the patient should be actually referred for screening in this case. Let us take a look at this path again. If you want to know how we compute actually those intervals that we see here, there, and also this probability, you can take a closer look at this slide. Yes, so we show here that we have three criteria which need to be combined. The first criteria is for any relatives in the family under 50 years of having a breast cancer. For such relatives, we need to have 2 cases. The next criteria is any relative is having or had breast cancer at the age of under 50 years, and also any relative from the family history of the proband had ovarian cancer. So, and the last criteria is for any 2 cases of relatives in the family history having ovarian cancer. So, for each of these criteria, we need to provide interval scores from this tool and from this tool, because the criteria that we have here do not map one-to-one to the criteria from these tools. Yes, that's why we get these intervals for each of the 3 sub-criteria, and then we need to build the union of this interval to provide the final answer. The final interval is from 8 to 26 for the family history assessment tool. Again, the Manchester scoring system gives us the interval from 6 to 16, obtained similarly to that of the family history assessment tool. The mutation probability needs to be obtained according to the Frank tables. This criteria is reflected in the Frank tables because we need to take here the table for the non-Ashkenazi individuals. Also note that we always compute the intervals for the female breast cancer because we answered the question of case of a male cancer with a no. Alright, the total for this probability is obtained from all the sub-criteria which are highlighted in this table, and the total corresponds to approximately 16% mutation probability. We also computed those scores and probability for several other outcomes in this tree. Please note that although this actual referral screening tool would not recommend genetic testing and screening for this patient, all other 3 systems recommend it. That is, a patient should be referred for screening or genetic testing also in this case. Now let's turn to conclusions. After reviewing the available material, we can observe that requirements for genetic risk evaluation in the genetic counseling and testing process of individuals and families should address the following key points. First, evaluation and verification and validation of process and their models should be standardized. This should include unifying risk factors across different tools and also the fusion of conclusions from these tools. The next point is that the data should also be standardized with a focus on the test participant numbers and age. An important factor is also origin of a participant, including such aspects as the geographical, national, and ethnic aspect. Next, the uncertainty in the data should be appropriately represented using suitable data types and also propagated using suitable algorithms. To this end, we presented the extended referral screening tool method, which attempts to do exactly that. Merging recommendations of the expert and a proposal for risk assessment and management is only meaningful after we have taken into consideration all the previously mentioned points. And finally, the consequences of risk assessment and post-test counseling need to be considered. Ladies and gentlemen, thank you very much for your attention and for the opportunity to talk to you today.